Okay, so today we're going to be doing chain rule, but we're going to be doing chain rule on problems that have the second derivative. Okay, so we're going to be taking the second derivative of functions using chain rule. Okay, so let's start off with something simple. Okay, now I have f of x equals 5 times 2 minus 7x to the fourth power. Technically, if I wanted to, I could sit here and I could distribute 2 minus 7x 4 times and find the polynomial and take the derivative of that one twice. But it's going to be much easier if we just do chain rule. Okay, now I'm going to use inside-outside rule on this. Okay, so when I do f prime of x, it's going to be 5 times the derivative of this. So I'm going to start with the inside. The derivative of the inside, the derivative of 2 is 0, and the derivative of negative 7x is negative 7. So that's the derivative of the inside. Times the derivative of the outside, we bring down the 4 and subtract 1 from the power. Okay, so here's our first derivative. Now before we go to take the second derivative, we need to simplify this a little bit. Okay, so when we multiply all of those numbers, we get negative 140 times 2 minus 7x cubed. Okay, so you take the first derivative, you simplify it, and then now we're going to take the second derivative. So f double prime of x equals, so I'm going to put down the 140 just like I did with the 5. Then I'm going to take the derivative of the inside, which again, the derivative is inside is still negative 7, times the derivative of the outside. This time it's going to bring down the 3, and then subtract 1 from the power to get 2. And then we're going to simplify our second derivative, and when we multiply the negative 140, negative 7, and negative 3, we get positive 2,940, 2 minus 7x squared. And this is the second derivative. So basically, we're just taking the derivative of the derivative. Okay? But we've got to do chain rule twice here. Okay? Now let's look at the second one. Now, you could, if you wanted to, do this doing quotient rule. I do not want to do quotient rule on this one. Okay? So what I'm going to do is I'm going to rewrite my function g of x as 8 times x minus 2 to the negative 2 power. So I'm going to use the bottom, bring it up to the top by using a negative power. So it basically makes this problem exactly the same as the last one. So take the derivative, g prime of x equals, put 8 times the derivative of the inside. The derivative of the inside here is going to be 1. Times the derivative of the outside, we move the negative 2 out front. X minus 2 inside, subtract 1, and we get the negative 3 power. Okay, simplify the first derivative by multiplying 8 times 1 times negative 2, which gives us negative 16 x minus 2 to the negative 3 power. Now, if I was only taking the first derivative, I'd probably move this back down to the bottom. But since I'm about to take the second derivative, I'm going to leave it right there. And again, so negative 16 times the derivative of the inside, which is 1, times the derivative of the outside, which is negative 3, x minus 2 to the negative 4 power. And then we're going to simplify this by multiplying the negative 16 times 1 times negative 3. So you get 48 times x minus 2 to the negative 4. Since we're done taking the derivative, we're going to rewrite this as 48 over x minus 2 to the fourth power. And that is our second derivative. Now, if you had done this with quotient rule, okay, you need to be very careful, because in the first derivative, when you take it, you're going to get low, so this, times the derivative of high. The derivative of the top is 0, because it's a constant, minus 8 times the derivative of the low, which is going to be chain rule, so it's 2 times x minus 2 to the first power, all over x minus 2 to the fourth power, because it's squared. You square the bottom. And you can see this right here, this is all 0. And look, you get 8 times, this negative 8 times 2, which gives you negative 16 x minus 2 all over x minus 2 4. And you can see that one of these is going to divide out with one of these, which makes it the third. And we get basically to there. Okay? But what my students normally miss is this part right here, is the derivative of 8 is 0, and it zeroes out that whole side. Okay? So be careful. Not to mention, adding up like terms and doing all that stuff in the quotient rule just makes it more difficult when you could be just doing power rule over here. Okay? And of course, and then even quotient rule, if you forget, if you flip them either way, it's going to mess you up at the end because it's going to be a positive and negative issue. Okay? All right, so here we go. Had to put some trig in there just to practice. So start with the first derivative. I don't have anything to rewrite here, so I just take the derivative. It's chain rule. So the derivative of the inside is 2 times the derivative of the outside, which is secant squared 2t. Okay? Now, I'm going to simplify this. Now, since I know I have to take the derivative and I have a trig functions to a power, I'm going to rewrite it, and I'm going to move that power so that I can do my chain rule easier for that second derivative. So what I did was, instead of writing it as secant squared 2t, I wrote it as secant 2t squared, which is the same thing. But now when I go to do chain rule, it's going to be a whole lot easier. So h double prime of t. Okay, so this is that initial 2. Now I'm taking the chain rule, and I'm going to do an inside-outside rule because I have a function inside of a function inside of a function. So the innermost, the derivative of 2t is 2, times the derivative of secant, and the derivative of secant is secant tangent, so I get that, and since I already took that, it's in both. And then times the derivative of the outside, which is the power, the third part, which is 2 secant 2t to the first power. Okay? And then again, like I said, we're going to simplify a little bit. And I got 2 times 2 times 2, which is 8. And then here I have secant of 2t times this secant 2t, which is going to be secant squared 2t times tangent 2t. And that's my second derivative. Okay? And then the last one, this doesn't look like a second derivative or taking the derivative twice, but it's asking me to find the instantaneous acceleration at t equals 1, given this position formula. Well, acceleration is the second derivative of position. So I've got to take the first derivative. So I'm taking s prime of t, which is velocity. Okay? So the first derivative is velocity. So take the derivative, it's 1/9 times the derivative of the inside, which is 3, times the derivative of the outside. So I bring the 3 out front, and I get 3t plus 1 squared. And then we're going to simplify my first derivative before we move on. So 3 times 3 is 9. 1/9 times 9 is 1. So we get 3t plus 1 squared. That is my velocity. Okay? But I need acceleration. So s double prime of t, which is the derivative of velocity, which is acceleration. So we are taking the derivative twice. Okay, so derivative of this, again, we're doing chain rule. Derivative of the inside is 3 times the derivative of the outside. Bring the 2 out front. 3t plus 1 to the first power. And of course, we're trying to find the instantaneous acceleration at 1, so we're going to plug in 1. So 3 times 2 is 6, times 3, plug in 1 for t, and then we get 6 times 4, which is 24. So that is our answer. So even though that didn't look like a second derivative problem, to find acceleration given position, and of course it does say the instantaneous acceleration, which deals with the derivative, versus the average acceleration. Okay, if it were average acceleration, we'd find the velocity equation and we'd have to plug in 2 points, but they didn't give us 2 points. It said to find it at this 1 point, t equals 1, so we know we were doing the derivative. Okay, so be careful.